My name is Kelly Kane, and I'm the Marketing Manager for E&M. Thank you for attending our S7-1200 ModbusTCP webinar today. If you're ready, be sure to check out our other upcoming webinars at enm.com. Our first webinar is on January 24th called PLC Programming Best Practices. You can register and find more information about this webinar on our website. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or email us at emwebinar@enm.com. Introduce your presenter for today's webinar, Hardik Tucker. Hardik is an E&M Siemens product specialist working with customers to design new applications for Siemens products. Good morning, Hardik.
Good morning, Kelly. Can you hear me?
I can.
Perfect. Welcome on to the S7-1200 ModbusTCP webinar. Happy Friday, and thank you all for taking the time today to attend this webinar. And you guys can see the screen, and there's a pretty cool picture, which is like what Siemens wants to call the factory of the future. And the vision there is just have one man and a dog. That is missing in this picture. The sole purpose of the dog is to keep engineer away from everything that's running in the factory. So that's pretty cool. All right. To be talking to and using today is the S7-1200 series family for the PLC from Siemens and the new TIA Portal software version 12, which is the generation TIA Portal software. T stands for Totally Integrated Automation, and kind of the next generation looking software automation, which helps us with everything for automation projects like DMIs, drives, networking, configuration, in addition to PLC programming. It gives great advantages, like we have a single database for everything within the project, and we maintain only one single project on multiple devices. It's a advantage, and we're using the TIA Portal software today. One feature of the TIA Portal software is its extensive communications library, one of which is ModbusTCP subroutine, which we'll use today. The S1200 is a brick-style PLC that Siemens offers. It's a compact form factor, a really powerful PLC with a lot of features. It allows us to combine several different protocols and field bus in a single unit. It's kind of nice because it uses the standard RJ45 Ethernet connectors. These of special programming cable and the USB to serial converters and the dongles are all gone. It's all capable of doing what's called Profinet, which we'll discuss in a moment, from which we can do multi-device protocols, including distributed I/Os. In this picture on the right side, you can see there is this green cable right here, which is a Profinet cable, and it's connected to the Profinet Ethernet connector on the PLC. And left side, the gray cable with the black connector is a Profibus connection, which is #1 field bus in the world. It's 485-based serial communication protocol, and it allows us to connect to several other third-party and Siemens devices and bring them in a real-time format. We also have a couple of other interfaces available on the PLC called ASI interface, which is the ASI. It's kind of two-wire power and communication signal at the same time, kind of little network. We also have additional point-to-point communication, which is the PTP. It's an RS-232 or an RS-485 typical communication that can be used for connecting devices like bar scanners, ASCII strings, etc. Then we also have what is called the USS, which is the Universal Serial Interface. It's a Siemens proprietary interface to talk to the drives. Then we have Modbus RTU, which is the RS-485 module or the RS-232 volt. And then the topic today is ModbusTCP. We are going to write a function block and pass some parameters to the block and see how easy ModbusTCP communication is via the TIA Portal software. The S1200 series PLC also has some additional features, built-in web server, copy and hop protection. And versions also have now is 2 Ethernet ports, which meets the need of an Ethernet switch. So we connect to the HMI from one port and the program PC to the other directly via the PLC without this need of a switch. New S7-1500 series PLC out, which is like a big brother to the S7-1200s. It's a faster processor and has several additional features and can handle a large number of IOs. Okay, so having said all this now, I'm going to jump into the TIA portal software right here. So here is called the portal view. It gives different options on how we want to get started, what we want to do with this TIA portal software. For example, we open an existing project, and on the right side you can see I have several projects that I've been working on, or we can create a new project. We can also migrate an older S7 project into the TIA portal software. There's a welcome tool, so if you guys want to see the welcome tool, it's a nice little video that Siemens came up with. It's interesting. Also, an installed software that shows what is installed on my PC. I have the latest version 12, Service Pack 1, Update 3 installed, and two basic versions of the TIA portal software. One is Step 7 Basic, and the other is Professional. And the only difference between those two is the basic version lets us work with the basic HMI panels and 1200 series PLC, while the Pro lets us work with 1200 and all other PLCs like the 300s, the 400s, the new 1500s, the PCs, which are the industrial PCs, comfort panels, and the runtime. What I would like to also point out is our websites. If we go right here, and in our website, actually also have all our next year's webinars, workshops, and training schedule up on our website. So if you're events, you can see training schedules, workshops, and webinars. Trainings are typically 4 or 5 full days, and we do full hands-on, detailed training on programming with the old software and the new TIA portal software. And in both Irvine and San Francisco locations, so if you guys want to sign up for that, you're more than welcome to. And we also have workshops, which are half-day, and they're typically free, and that shows and covers basics of the S7-1200s, HMI, and the drives, and 2-hour little hands-on lab that we put together, and you can go to 3 different hardwares and make it communicate and make the drives ping. All the fun stuff. Also, we have an online portal where you can buy stuff. So you log on to our website, and after webinar, if you think, oh, the S7-1200 seems pretty cool and you want to try out Modbus communicate for it, you can log on to our website and you can see the smallest S7-1200, it's only $190. It comes with 6 digital inputs, 4 digital outputs, 2 analog in, and an Ethernet port. Also, right next to it, there is a spec sheet, PDF. So if you click on it, it will simply open the spec sheet, and just real quick go through the complete spec sheet of what the PLC is going to support and what it offers. Sorry. Also, there are 4 different kinds of 1200s. You can see there is a 1211, there is a 1212, which is 8 inputs, 6 outputs, and 2 digital, 2 analog, sorry. Then 1214, which is 14 digital in, 10 analog out, 10 digital out, and 2 analog in. And then we have the 1215, which I was mentioning before, has 2 Ethernet ports. It has the same inputs and output as a 1214, but has 2 Ethernet ports on it, and it can do faster drive communications for motion applications. Let's go back to our TIA portal software and go ahead and create a new project. Call it bus, and let's name it Friday the 13th. Let's go ahead and create our project. So we do is create the project where we'll save all our projects that we do today. Now if you see, the screen has changed. We are still in the portal view, and now it's asking us how do we want to start today. So it's various different things like device and network, and configure a device, which would be our hardware configuration, or we can jump into PLC programming and just start writing our code. We can also configure and do motion and technology blocks. So motion side does all the drive applications, and the technology objects are like PIDs. You can configure an HMI touchscreen, or you can also configure and parameterize a drive. So the new TIA portal, the drives are all integrated in the software. So we can all three PLCs, HMIs, and drives with the same single software. So you don't have to learn different software packages. So let's head and jump. When we select one of this option, it takes us to the project view. So let's go jump directly into our project view. Now the screen is changed. On the left, what we see is the project tree. So this is the navigation area to everything inside our project is easily accessible from. We select something in this project tree, there are details view right below it that shows a little more details of whatever is selected on the project view. You can see the software is the same Windows layout, so it gets all Windows options like cut, copy, paste, drag, and do. Zoom, feel, and look. We got all the tabs right here, like we get on any Windows application. And the center, what is called, is the main working window. So we have selected on our project tree, comes up here on our working window. And right below the working window, you can see we have a few tabs like properties, information, and diagnostics. Whatever we have selected here comes up on the properties and information right below it. And on the right side, we have is a context-sensitive area called tasks. So depending on what we have selected right here, this area keeps on changing. So the software is really interactive and intuitive, and we'll see that how the software works. So let's go ahead and add a new device to our system. So select a new device. It gives options if we want to add controllers, the PLCs, or some HMIs, or a PC system, or some drives. Today we are going to add what is the S7-1200 family, and because I have the professional version, I have options to select 1200s, 1500s, 300s, 400s, and 200s remote CPUs. So if we go down on the list of the 1200s, like we talked, there are 4 different flavors of the 1200s. Each of 4 of it, there is 3 different options that we can select: DC relay, DC-DC-DC, or DC-DC relay. And the differences are, the first one is what kind of power does the PLC take to power up the PLC. So in case of AC, it is AC powered, 120 or 230, and on DC, it's 24 volt DC powered. The second, DC, stands for what kind of inputs are there. So they are all DC inputs. It can be NPN or PNP, depending on how you jumper the pins. And the one is the outputs, which could be either relay outputs or DC 24 volt outputs. An option of unspecified CPU. This is pretty cool. Let's say you don't know what is the model number and the specific CPU you're working with, or you have multiple CPUs connected on the network, and you work with one CPU specifically. You can simply select and say unspecified CPU. What that does is the software will go out and detect everything that is connected on the network and up on the screen and say you have this CPU connect the network, which one you want to work with. And there's also a feature of flash LED. Once you click on it, it will flash the CPU, so you know that this is the one you want to work with, and you can just select the one that you want and bring it in the project. Let's go ahead and select, let's say, a 1215. So I'll select the 1215 and bring it in our project. Now you can see the 1215 CPU, and it's a graphical interface in the software, so you can see the actual front view of the CPU, how it looks. And then you can see there is some age loss on the right side of this CPU. Also, a neat feature of this 1200 is it's a standard DIN 35mm rail mount, so you don't need special racks for it. You can use regular DIN rail and just mount the CPU right on the DIN with other components. So on the right side for the 1215, there's an option to add 8 different I/O modules. Now you can see on the right side on the tasks area, now options of hardware catalog. So with the options of what do we want to add on the right side. So if we go to digital inputs and outputs, we have digital ins and out, and we can just simply drag and drop an I/O card on the right side, or we can also double click on it and bring it right on the next available slot. So I'm going to go ahead and delete this for 1 second. And also another feature on software, which is change device. So let's say we started working with 12.15 and we speculated that we will need more than 20 IOs or 10 IOs. And so we decide, oh no, we only need 2 IOs, and even a 12.11 CPU can do it. So you can simply go ahead, right click and say change device and show us what is the current device and what are available new devices from the same product family that we can swap this device with. So let's say we want a 12.11 DC. Go ahead and simply click OK. It will tell us that this port had 2 Ethernet ports and this one has only 1 Ethernet port. So we'll say we don't care. Let's go ahead and change it. So see, all the 8 IO racks on the right side are now all gone. So this CPU doesn't support any additional IO cards. But there's a trick on how to add IOs to even this CPU. I'll show you that in a little bit. So let's go ahead and add a Profibus RS485 module. And if we go to communications module on the right side, for Profibus, we see CM42 and CM1243. 42 is a switch device and 1243 is a master device. So let's go ahead and add a CM1243 for our project and double click on it. And notice it came on the left side rather than going on the right side. It is an interactive software and really intuitive. So we can drag and drop also. So if we want this one, we can drag and drop on this 2 of the next slots. Or we simply double click on it. We don't know where it goes on our hardware configuration. The software automatically put it to the next available slot. So for 12.15, we can have 8 IO modules on the right side and 3 communication modules on the left side. So it's pretty, if it goes on the left side, we don't take over our inputs and we don't have to lose any inputs for communications. Now notice here we have 3 different tabs, which is device view, the network view, and topology. If you go ahead and click on network view, our view changes. We still see our PLC, which is a 12.11c, and there's some network connections and more capabilities that we can see here. Remember, I told you there's a little network trick we can use to add more IOs. So how do we do that? Our hardware configuration of catalog open on the right side. So we go under distributed IO. We see different ET200SP, M, ISP, and ECO. The ECO one is an IP67 waterproof rated distributed IO. So if we go under PN, which stands for Profinet, and we go under Profinet, we have digital ins, outs, and analogs, and IO link too. So let's see what's under digital in and out. We got an 8 in, 8 out. We can simply drag and drop that. Now if you notice, it says not assigned right here. That means is we brought in the remote IO, but it's not assigned to a master PLC. Going back to the point how easy and interactive the TIA portal software is and how to do networking, typically it gets really complicated, but not with TIA portal software. You see the green box right here, which represents Profinet, and there's a green box, which is our Ethernet Profinet connector on our base CPU. We select the green box and drag and drop a line and connect it to our remote distributed IO. You see we just created an Ethernet connection between our PLC and the remote IO. Now, and once we download it to our CPU, it will start talking to the remote IO. Also, the software is really interactive. So if we click on one of these green ports right there, like the properties, it will take us to the Ethernet properties, the Profinet properties, and we can see what Ethernet IP address it is at. If we click right here on the IO and select, so now we can see our PLC was at 192.168.0.1 and the remote IO is at 0.0.2. We want to change the IP addresses. We don't have to go inside and figure out where exactly my Ethernet options are and my IP address options are. you can just simply click on the box and it will take you right to the properties and easy and fast navigation. You can notice there is this purple box, which is our Profibus connection. So let's go ahead and add another remote I/O and go under Profibus this time. And let's say we have a digital out, 16 digital out. We can drop. You see again, it is not assigned, and this time the box is purple. So ahead and drag and drop a line between those two boxes. Now you can see we just created some remote I/Os and we added I/Os to our 1211C, and we have 16 digital outputs here and 8 digital in and digital out. And this is worked on Profinet, which is the green line, and this is networked on Profibus, which is like a pink line. We just hardware configuration of a 1211 CPU with some remote ET200 Eco I/Os. Because voice view, then our rack, how it looks again. So we have a conveyor system in our factory, and we have some boxes passing through the conveyor, and we want to count number of boxes. So how do we add and do a small little project program to count the number of boxes? So if we look in our project tree, we have several options under our PLC, which is the CPU 11C configuration, which we just did. We can go online if we have the CPU connected to the Ethernet port inside and look what's going on inside, and if there are any previews. We can also look at the diagnostics buffer, which is all the built-in capability of the 1200, and go and see it's all date and timestamps, so we can exactly what were the faults that previously occurred inside our CPU. The one below it is our programming blocks, and that's where we're going to work to do programming. You can see the options to add a new block, and we already have a main OB1 block created for us. OB stands for organization block, and the OB1 is the main block, which is like a cyclic block that keeps on running inside the CPU. The processor calls this block, it's like the main block that's always running. Whatever we do, we can do programming inside the block, and the CPU will do a scan cycle for OB1 every time. So let's say there is a 10 millisecond cycle time. Depending on what code we have, this block will run every 10 milliseconds. Or you can also do what is called structural programming, and which seems it's really easy. You can simply go ahead and do add a new block. Once we click add a new block, we have 4 different kinds of block we can add. One organization block. So if we click on it, it tells us a little description of what those are. Those are the same OB, and we have different options like the OB1. We want any of those options. Then there are function blocks, function, and the data block. Go ahead and create a simple function for now, and let's call it conveyor. Okay. Okay, you see how the screen changed and our main working window changed, and now we are inside the programming window, and it took us into the conveyor block, inside the conveyor block for program. And you can see we have some of our normally open, normally closed, and some contactors right here. So these are like my favorites that we commonly use. And on the task area, we now have a different basic instructions, extended instructions. These are all the instructions that we can use for our PLC program. So we talked about before is a counter. So if we go and look for counters, and under counters we have IC counters, and we have 3 different options: count up, count down, or count up and down. So let's go and simply drag and drop a count up timer. You will notice there is a pop-up that top up is a data block. So it's asking us where do we want to save all the data for this count up timer. We'll simply say I want to save it in the default data block and hit OK. This cool feature about the Portal software is the help. So say if we have this block selected and we hit F1, it will into the help directly for the block what we need help for. So now it's a count up and it shows a description. You can use the count up instruction to increment the value of the output CV. Signal state at the CU input changes from 0 to 1, which is a positive signal edge. The instruction executes. The current counter value at the CV output is incremented by 1. If we scroll down, it shows us how is it different between the 1200 and the 1500 CPU. It also shows us what are the different parameters that the block is expecting and what the abbreviations stand for, the CU, R, PV, Q, and CV. And here's the description. CU is the counter input, R reset, P is the preset value at which the output Q is set, Q is the counter status, which is on or off, and CV is the value of the counter. There is an example on how to write code using this block. So it shows us some tags and some values and how pretty much we can write the block. So let's close this for now and go back to our block. So let's say we had a photo eye. So we don't normally open contact. So we can just say drag and drop and put it here and call it right. Say we want to count 100 boxes. You notice there are question marks, so it's expecting some value, and when I scroll my mouse it shows me that it's expecting an integer or a word value. So let's go ahead and type 100. So I'm going to count 100 boxes, and on 100 boxes, let's say we want to turn a light on. So let's just call this a light. If you notice, we have red lines below our photo eye and the light names that just assigned to our programming. What that means is give it some names, but the PLC is expecting an address to where this IOs are mapped to. So we can right click on it and say I want to define this tag, and we want in the global memory, and let's say it's connected to input 0.0. So our server is connected to the first input and our light is connected to the for output. Now we just find it, and let's go ahead and compile it to see if there is any errors. So if you notice, this area now changed and it came back with a compile area and gave us 001. There's one more feature. So if we go back to our PLC on this picture and double click on it, and let's say if I zoom, you view all the IOs right here. So the first input is now described as photo eye and light. So let's bring some inputs and outputs, and I don't know what I used in my code and what I left out. I can simply go back here and look, okay, my inputs are empty and this outputs are empty, and this is where my light and the photo eye are. So it's pretty cool. So we just created a small count up block using BC counter, and whenever our box is going to pass through the photo eye, and when the count gets to 100, we'll have a light turn on. But to do one more thing before we download this to our PLC is our main OB1, which is our main cyclic block, and just simply call this block from our main OB1. So when the main OB1 is running its cycle, it's going to come in and go call the conveyor block, and it's going to jump to the conveyor block and run and executes inside the conveyor block and get back to the main. So let's go ahead and save our project. So let's had this conveyor running for a few years and was counting all the boxes, and we had the lights coming on and off. Oh, one thing that we forgot is to reset. What will happen is after 100 boxes, the light will never be reset. It will always stay on. So let's go ahead and also add a reset to our block so that we can reset the light. And again, we need to define it. Go ahead and define it to input 1.0. Now our block is completely defined. We make sure we compile it, no errors. Okay, so let's say we had this running, and suddenly after a few years we hear our factory and we are getting a new SCADA system installed. SCADA means supervisory control and data acquisition system. And we'll talk a little more about it in a second. And typically all the SCADA systems, most of them are using Modbus. So now we have to implement Modbus using our existing Siemens PLC and our code that we have written and talk to the SCADA system that we are getting. If I jump right into little Modbus Wikipedia, so what is Modbus? is a serial communications protocol which was published by Modcon in the late 70s. It is a serial communication protocol, and it was an open standard, and one unique thing that Modcon did was it developed it completely and then put it as an open source, royalty free. So anyone can use Modbus protocols and use it for industrial communications in their software automation needs. So at the time, it was really easy to deploy and maintain industrial communications for all the serial devices, and a lot of industries kind of adopted and standardized Modbus for industrial communications. Going to SCADA, which is supervisory control and data acquisition systems. So control means that it will just control and tell a PLC to perform tasks. Let's say run a pump to fill a tank. But the logic to perform and maintain the task is performed at the PLC level or the remote terminal unit level, which are RTUs. And the data acquisition side of the system will collect the data from the RTUs, which are remotely collecting local data from the local devices, and they feed those data back to the SCADA system. So this system is like a central hub, and it goes to the remote terminal units, and the remote terminal units get data from local devices connected and feed it to the SCADA system. But nowadays is the PLCs have become so much powerful that perform the task for both running and executing a process, and also act as an RTU to report back to the SCADA system. The communication enables us to approximately connect between 240 devices connected on the same network. But with the Modbus serial communication is it's kind of slow, usually around 32K baud rate. So you have a few hundred devices connected. It will go and be pulling data from each device one by one, and it just takes time. So the update rate will be a few seconds. For Modbus, there are three different protocols. The first one was Modbus ASCII frame format, which is a typical two-wire serial RS-232 communication. One is Modbus RTU, which is to the ASCII, but it does it in a binary fashion. So it's more compact and more efficient. And the next one is the Modbus TCP frame format, which is Ethernet-based, which is much faster communication protocol. And the same Modbus communication format. So what that means is they all use the same common registers, which are the 10,000s, the 30,000s, and the 40,000s. And we'll see later on what those registers mean. So if we back into our TIA portal software right here, so now we want to implement Modbus communications. So we can simply go ahead and add a new block to our existing project. Say, let's call that function Modbus. We hit OK. So now Modbus block. If we go on the right side in our instruction area, we can see there is a communications library right there. Let me scroll it up. Close this. We have different options like S7 communication, which is communicating between the S7 PLC family. So if you want to talk between a 1200 and another 300, 1500, you can use these commands. Then we have open communication, talking via Ethernet. We also web server, that is www. And if we go under others, we have Modbus TCP. So under Modbus TCP, we see we have two blocks that are predefined, which are communication via Profinet as Modbus TCP client or a Modbus TCP server. We had a CM1241 Modbus server before, so let's go ahead and drag a Modbus server block right there. So again, it's asking us where do we want to save the data. I'll just say defaults and hit OK. So here is a typical Modbus TCP server block, how it looks. We select it and hit F1 again. It takes us to the help file, and it shows us what different parameters and what do they mean. So disconnect, if we want to disconnect the block from communication, connection ID. It's pretty much a unique connection ID. It can be anything 1, 2, 3, 4. It just needs to be unique so that the CPU knows what connection it is being connected to, what kind of Modbus device. TCP port typically default at 502 for Modbus devices, and there are more instructions that we can change to different TCP port. But we want to use 502 for today. If we go back, it's already named 502 when we brought it in, so we're not going to change that. Then other optionals on the right side, which is ER, DR, error, and status. So those are some status bits that we get if there is an error, or if there is error code, the data is read-only, and the new data is read. So let's go back and give it a unique connection ID. Let's just say we'll give it 1 because this is our first Modbus device that we are going to talk to. And if it is question marks, that means it is expecting some value right here. And on this side, it's all 3 dots. That means it's optional. You don't have to put any values over there to make the block function and work. So if we go back to our help right here and click on MD hold register, we have 40,000 registers right here. If I go back real quick and scroll down here, this is the mapping of the Modbus addresses. So right now with this block, without even defining any value in the MB holding register, what we just did is we mapped all these Modbus functions on any typical Modbus network with different addresses or the registers, 1, 10,000, and the 30,000s to S7 PLC process image area and the CPU addresses with which it default maps to. So we don't map it again or define that 30,000 corresponds to this. It's already done for us. So we get some discrete inputs, outputs, and we all get some words which are the 30,000 registers, which are the typical analog modules. Go back to our MB device. You can see the 40,000 registers here for Modbus addresses and the corresponding value on the PLC. What I was mentioning before is also data block. So if we have created our data block, which we will do in a sec, we can also use a pointer to point to a specific data block. Now let's just go ahead and copy this default and go back to our logic and just paste it there. So pointing it to memory word 100.0, word number 5, and let's compile it first. So that's it. What we need to do for a Modbus TCP server block. But we need to one more thing is go back to our main and then call that block from our main. Oops. Make sure we do our project, compile it again, no errors. So what we just created and added to our existing conveyor project is a Modbus communications block, which is a server, which would give out data from this pointer at memory word 100, word 5 to a Modbus device. Going back to what we were describing before was data blocks. So go back to add new block, option of data block. DBs are data areas in the user program which contains user data. So helps is, let's say we already had our project running and we're using some IOs and M bits, and we don't want to overstep on the current M bits that we are using at different values, different blocks inside our project, which is already running, and writing it over again. So create our own DB, and it's accessible globally. So let's call it global data block and call it plus holding register. We can create our own DB, telling us what do we want inside our DB. So we will use it for the 4,000 registers. So let's just call it 40,000, and can change what kind of data type we want. So different options here, a lot of options on what kind of data we want inside our data block. Let's then select an array. So I'm going to make, let's say, 100 registers. So I'm going to go from 1 to 100. Type, we want it to be word because we know its data type is word. So we can go back here And if we see what it is, we know that it is Word format. So we just created 40 words inside our data block, inside the PLC logic, without stepping any of the current embeds or the IOs that are being used for our conveyor block that was running fine before. So if we go back to our Modbus block and this enter, we can delete it, and I want to use my data block that we just created. So if I click on the Modbus holding register block, it takes me to the data type inside, which is 40,000 register. Select this 40,000 registers. It shows me all 100 registers that I can use from. That's 40,001. I'll select 40,001. So now I map the 40,001 register on the Modbus side to a whole data block that I just created, called Modbus holding register. So now it's going to hold the value right here and communicate with the 40,001 register on the Modbus. Go ahead and compile it. Make sure. Oops. I'm error because I created a block, but we never compiled that block. So the CPU doesn't know the block exists. So now you can see the errors are gone. So when we put the whole logic to the PLC, we have to make sure we also compile the Modbus data block that we just created and also transfer that holding data block inside the CPU. So if we go back to our conveyor block, so we will change all this to the new data registers that we created. So we can go ahead and say I want to call it global data block. Well, it will give us an error because these are booleans, which are inputs and outputs, and we created it as a data block so we can use it. So going back to the topic of passing the registers or passing values to a block. So if you go up right there, you can see some inputs, outputs, and temporary variables that we can use inside our block. It's our counter block, and we want to make a generic counter block that we can use for any PLC or any IOs, or we can even share it through our company's network through global libraries. How do we create a block and pass some parameters to it? So we have three values. We had the photo eye, the light, and the reset. So inputs were photo eye and the reset, and output was light. Created three booleans, photo eye, reset, and the light. If I go right here and type photo eye, you can see I get two different options. One is the purple one, which is the global input at I0.0, and the blue one with the hashtag in front, the local one that we just created up top right here. Let's go ahead and select this local variable photo eye. We'll name thing for the light, hashtag light, and reset. Let's then compile it again. Now if we go back to our main OB1, you will see there is a red block right here. That means something is wrong with this block. So they can say update the block. It will tell us the old interface was like this, and now the new interface, because we made the changes to pass parameters to the block, has become like this. If we hit OK, you can see the block is changed and there are a bunch of question marks, which means it's expecting some values. So what we did is we just created a generic conveyor block with some kind of sensor input and a reset input and a light output. So I can use the same block over and over in my multiple projects, and depending what inputs and outputs my POI and reset buttons are connected and the lights are connected, I can just simply change those IOs. So if I'm back again and I know for this project it's at input out 0, the reset input 1.0, the light is at 0.0. Go ahead and save the project. Oops, I hit the wrong button. Down it and complete. Make sure everything is good. So now we just created a block and passed some parameters to the block. So go ahead and briefly overview of what we just did today is we created hardware configuration for the PLC to 11, and we added some remote devices, the remote I/O, Profinet, and the Profibus. Then went ahead in the programming side, and we created a small count up timer for a conveyor, and it's a Modbus TCP programming to make the PLC a Modbus master and communicate with Modbus slave devices. We also created an array of 400 words to tag to map it out to the 40,000 registers on the bus device. And that's pretty much it. So let's see if we have any questions. The question I see is, how do I upgrade from V11 to V12? Good question. So if you go back right here, you can simply call 866-893, our hotline, which is my ENM, 866 my ENM, or you can email us at sales@enm.com, and special upgrade packages so that you don't have to buy the new software again. And one of our inside salesperson will be more than happy to send you a quote and the right part number on how to do an upgrade from 11 to V12. Next one is, I'm getting new system and the specs call out for a comfort panel. What is that? Okay. So if we go back into our TIA portal software, panel is another kind of an HMI. So we have two panel types, like basic panel and a comfort panel. The comfort panel has a few additional features that the basic panels does not have. And C is also coming out with new basic panels, so they are upgrading all the basic panels to add a few additional features on the basic panel. So if you go on our network view, you see there is an HMI right here on our catalog. There is panels, comfort panels, mobile panels, push button panels, different kinds of panels. So under comfort panel, let's say a 9-inch comfort panel, TP900, we can all bring that in our project. So you have HMI is networked to the project, and you can another green box right here. So I can go ahead and connect that to that. So now it's brought in a comfort panel inside our project along with our CPU and the existing remote I/O, and we will need a switch here because we don't have the 1215, and we just brought a comfort panel in and we can program our comfort panel. So that's pretty much all the questions I can see. I'm going to pass it over to Kelly, and thank you everyone. Kelly's got any more questions?
Great. Thanks, Hardik. That sounds good. Anyone would like to review a portion of this webinar, a recording will be available on our website, enm.com, by Monday afternoon. Also, if you think of any other questions after this webinar, feel free to email us at enmwebinar@enm.com. And thanks, everyone, for attending.
Guys.